This episode is brought to you by IT Revolution, whose mission is to help technology leaders succeed through publishing and events. You're listening to the Idealcast with Gene Kim, brought to you by IT Revolution. In this episode of the Idealcast, I'm so delighted that I have on Mike Nygard, currently VP of Enterprise Architecture and Platform Development at Sabre, the software and technology company at the heart of the business of travel. Incidentally, it is Sabre in the 1970s who pioneered the entire category and capability of travel reservations and booking. It is difficult to overstate how much of my own work was deeply influenced and inspired by Mike Nygard. I remember reading his seminal book, Release It. It was on a plane, and I remember feeling not only sick reading it, but also angry. I wanted to throw it across the cabin because Mike was describing so many problems I had seen in my career with such incredible clarity. And he was describing the incredibly elegant solutions required to mitigate so many of those problems. His work has pioneered patterns that we're all familiar with now, such as circuit breakers, the bulkhead pattern, chaos engineering, and so many more. And here's one particularly memorable interaction I had with Mike. It was at the Velocity 2013 conference in Santa Clara. Among many other things, Mike showed me Clojure, the programming language that reintroduced the joy of programming back into my life. It is now why I self-identify not as an ops person, which I've done for 20 years, but as a developer. In this episode, I learned so much from Mike about so many things, including how we can enable thousands or even tens of thousands of engineers to work together towards common objectives. What are the structure and dynamics required to do that? What are the real implications of Conway's Law? What great architecture looks like? And his definition of architecture, which includes the notion of the organizing logic and means of software construction, and specific examples of how he's helped business and technology leaders in their transformation journeys over the years. Mike, I am so glad that you're with me on this podcast. So I've described you in my words. Could you describe yourself in your own words and tell us what you've been working on these days?
It's definitely easier to describe what I've been working on, but I'll try to describe myself a little bit. Almost more than anything, I think of myself as someone who tries to understand how things work. The systems that we work on as information systems and technology systems, but also the systems of culture and business and finance and physics that really define the world around us. So I often feel like too much of a generalist to really put myself in any one category. If you look at my experience, the work experience is primarily as an architect and developer with some time spent in operations and sales and management along the way. The thing that I'm working on right now is a major technology transformation effort at Sabre, where we are trying to recreate the business of travel and recreate ourselves and our systems, dealing with a considerable legacy of what we variously call heritage technology, classic technology, legacy technology, and so on, where at any given time, we'll have a GraphQL query coming in via HTTP at the front end, and at the back end, we have a teletype message going out to an airline or a baggage claim.
At the heart of it is a famous TPF system that goes back, I imagine, 40 plus years. Is that right?
Absolutely. In fact, it appears that TPF was in some way factored out of the original Sabre system back when Sabre was not the name of a company, but it was actually just the name of the machine. It was the semi-automated business research environment, which was that specific mainframe that was being used for the reservation systems for American Airlines.
And TPF is the operating system that runs on the mainframe that is not the ZOS, that has some magnificent properties. Is that right?
Yeah, I sometimes think of it as the land that time forgot. It's built like a real-time operating system. It loves interrupts. It loves very quick transactions. It hates batch jobs. It's kind of the opposite of ZOS and MVS.
Gene here. Before we leave the topic of TPF, I feel like I need to explain the marvel that it is. It's a real-time operating system that runs on IBM mainframes. Wikipedia describes it like this. TPF delivers fast, high-volume, high-throughput transaction processing, handling large, continuous loads of essentially simple transactions across large, geographically dispersed networks. I was talking with Rosalind Ratcliffe, a distinguished engineer at IBM, who the DevOps enterprise community knows so well, whose area of specialty includes mainframes. She told me this: Google is famous for its scale, processing something like 70,000 searches every second. Around the world, the z/OS mainframe platform collectively does 2 billion transactions every second. But she added, if you include TPF, that number would be around 200 billion transactions every second, which is collectively 7 orders of magnitude more transactions than what Google handles each second. This should give you an idea of the scale that TPF operates at. All right, back to my interview of Mike. Great. So you mentioned in your career the strange path you've taken, and I mentioned the Release It book. And I think it's such a marvelous book. And with some hindsight, it seems now obvious to me that this is a book that could only have been written by a true boundary spanner, someone who has walked in the shoes of a developer, of an operation person, and an architect. And by the way, when I was writing the Unicorn project, the protagonist, Maxine, was in many ways modeled after you. And
oh, wow.
It's so amusing to me that when people read the book, kind of their reaction is like, holy cow, she seems like a superhero, right? So can you tell us...
That must be why I liked her so much.
Yeah. Can you tell us the story of how you ended up gaining this unique type of perspective that allowed you to write the first edition of Release It?
Pretty early on in my career, I had the experience of being an operator for networks of Linux machines. Now, it happened that these were all virtual machines running on a Unisys mainframe as part of a federal government contract. And I was the only Unix person in this entire Unisys facility of mainframe programmers. And so I was the only one who cared about the Linux machines, which also meant I could break them and recreate them. And they were all virtual machines, so I could create as many of them as I liked. Each one had their own file system. So I got to do a lot of administrative work in the safest possible environment. It was
by the way, what year was
mainframe. This would have been 92, I think. 91, 92, somewhere around there. All of that got delivered, and we did some crazy stuff. Like I had to, as part of a POSIX compliance effort, I wrote a version of VI that worked on a full screen synchronous terminal. So imagine you edit your whole screen full of text, you go down to the command line, you hit submit, and that sends the whole page of text to the mainframe. And then turn it into VI commands and all of that. So that experience sort of set me up understanding running the software as well as building the software. And I took that with me into all of my early jobs. And really, at that time, there wasn't as strong a divide between development and operations as we started to see in the late 90s as the web and large-scale systems really spun up. It was around 2003, I think, 2002 or 2003, when I was looking for a contract. I had come out of a consulting partnership and was looking for something to kind of fill the time, let me relax a little bit, bring in some money, but also re-energize and heal a little. It didn't end well. So I took a contract that was in operations supporting applications in what turned into a very large commerce system launch and turned into my kickback and relax contract turned into 70 hours a week for 4 or 5 months at a time, including some really dire situations. So, we had a lot of software that was getting rushed out. It wasn't all fully tested. Some of it scaled very, very badly. The first load test we did, we were expecting to get to 25,000 sessions. We got to 400 and everything locked up across every node in the cluster.
And then went down to 0.
Yeah, it went to 0, right. Yeah. So what's interesting is how much you learn when things are broken. If you're faced with a piece of technology that just works, you learn almost nothing about how it's constructed. But when it's broken and you have to fix it repeatedly, and it keeps breaking in different ways, you learn a tremendous amount about that. Because I was someone in operations who had come from development, I was able to go in when all of our threads were locked up and pull stack traces and just find out why it was locking up. And so I would feed that back to the dev team with, line numbers in the source code. And they said, but you don't have access to the source code. I'm like, come on, really? Like, you give me a jar file, 5 minutes later, I've got a version of the source code, So that was this interesting experience where I was in operations, and I thought that most of our break fix work was going to be around dead CPUs or burnt out fans or failing hard drives. And absolutely not. The overwhelming majority of our problems were software created. And so I looked at this and I'm like, this is embarrassing. This is costing us a lot of money. Like, why would we put this software out here when an hour of downtime is going to cost us $10 million? We saved a couple of weeks of development, but we're losing $10 million, every other week or so when this stuff crashes.
Yeah, in fact, you tell the story in your amazing 2018 DevOps Enterprise talk on tempo, maneuverability, and initiative, which we'll get back to later. But there was a part of that story that really struck me, which was that immediate ability to have a high bandwidth communication with your development counterpart, right? Because you were talking in the language of, was it ports, sockets, and something, so that you could actually quickly work together to solve the problem together. Do I understand correctly that you were actually part of a sort of an outsourced operations organization? You were able to span a very complex boundary?
Yeah, that's true. This was a startup called Totality, which eventually became acquired by Verizon and became a function called remote application management. So our premise was operation software at the time was very expensive. Certainly staffing an operations center 24/7 is very expensive in equipment, in personnel. And so our value proposition was you can amortize the cost of doing that by, sharing the expense. So you're renting a portion of our operations capability. And yeah, that's another place where I was one of the software people in operations. So I was initially chief engineer for my commerce client and eventually for the whole central region of the US. And the ability to talk in a language that met the developers really helped. And this is something that I've done a lot. You mentioned boundary spanning. And I think when you are encountering a boundary between disciplines, you don't need to learn everything about the other discipline, but it does help to learn enough of the language to be able to communicate with the denizens of that domain. So when you're talking to database people, you probably talk about tables and columns and data types. Maybe if you're an experienced developer, you can talk about whole table spaces, or increasingly these days, shards and segments and so on. But you're probably not talking about cylinder layouts or LUNs or the SAN behind the HBAs and that sort of thing. Likewise, when development and ops talk, it's really best to meet those concrete artifacts, like you mentioned, machine names, ports, files, locations, that sort of thing. If you come in and you say, my visitor pattern is overtaxing the garbage collector, the ops person is likely to kind of go, well, okay, that's interesting. I don't know what you want me to do about that.
And I think that's really one of the marks of a great boundary spanner, right? The ability to speak in the language of the denizens of the domain that you were speaking to. Is one of the things that I started to pick up in your areas of interest was the notion of how do you get large groups of teams to work towards a common objective. And in the very last moments of your talk, you start talking about how do you get everyone moving towards a direction, accomplishing things in the easy path rather than screwing up and having to recorral things and moving back into a realm of centralized control. Is that a problem really? And if so, what makes this so hard?
So it is definitely a problem, and it's something I think of as a day two problem or maybe a year two problem. And it's one of these interesting transitions that you need to go through. Many organizations in need of transformation are too much in the command and control space. And a lot of what they need to do is decentralize and liberate their people, create some autonomy. Once you have done that, then you're faced with the question of, okay, now we've got autonomy, but we're faced with an existential challenge in the marketplace. how do we realign around that? And I can use metaphors. I think of it as, you create a magnetic field so all the iron filings line up in the right direction. Within Sabre, I've been talking about how, okay, we've got a super tanker, which is very efficient, but not very flexible. It can only go certain places. It takes half of Texas to turn around. What we want is something that's much cheaper to replace, or that we can replace individually, that can go more places. We want a speedboat. Actually, we want a lot of speedboats, but we want them all going in the same direction, because otherwise they'll crash into each other and sink. Well, once we get past the metaphors, it gets a lot more challenging. If you think about kind of the tools available within an organization, one of them is vision setting. So communicating a vision that people can feel connected to and see the connection to their actual work. And this is vision of a different type than saying we're going to be, I don't know, the greatest company to work for in the US, right? Like that doesn't really say anything. We're going to be customer focused. Okay, that's great, but I can undertake almost any initiative I want and tie it to the notion of being customer focused, right? So you have to create a vision that is audacious, consistent, and that people can tell if they're proceeding towards it or not. So again, with the metaphors, some people will refer to that as a North Star. But imagine you set out a vision that says a customer should be able to get up and running within our system in 10 minutes and deactivate just as quickly. Well, that's going to require action by a large number of different parts of your organization, right? So you've got some UI work, you've got some back-end work, whatever your billing system has to be aware of this. You may need to change some of your customer care procedures. Instead of having a recovery script and a special group that exists just to annoy them until they hang up, you need the ability to hit a button so that they're deactivated. So it's still a vision, but it's a vision of a different sort. It's somehow more attainable or more actionable. Another thing that really helps, maybe one of the greatest accelerators of all, is trust in your comrades and in the other teams. And that's trust laterally and vertically within the organization. I've read a lot on how that trust gets created, and it turns out there are different ways of doing it, but they don't mix all that well. So one approach is you have a group of people who've all been through the fire together. This is common in the hyper-growth stage of startups, right? You're kind of going through this expansionary phase where you take the dozen or so people that formed the nucleus of the company before, and now each of them has a group of 100 or 200 that they're trying to align. Well, that dozen has a great deal of trust for a while, and that can help. If you have a common training method and doctrine, as you would see in a military organization, that can create trust as well. So there are different mechanisms to achieve it, but trust is also pretty essential. And then Don Reinertsen talks about another method for creating a distributed action with autonomous teams all heading in a direction. And that's what he calls decentralized economic decision-making. You might have read this in his fabulous book, The Principles of Product Development Flow, an example from the development of the 777 aircraft, where an engineer was authorized to add to the purchase cost of the plane if he or she could reduce the weight of the plane. Because they had done the analysis of the economics and said a pound of weight has to be carried on every trip back and forth that the plane makes. And so customers will pay an extra, $300 for 1 pound less of aircraft weight. If you can figure out what your sensitivity is and publish that kind of a metric, then it's fabulous to get people aligned in the right direction. Sadly, in a lot of fields, it's not quite as clear cut to define as with the 777.
Gene here. Mike mentioned the amazing works of Don Reinertsen and his incredibly brilliant and seminal book, Principles of Product Development Flow, which framed and codified how so many of the lean principles could be applied to product development. I love that story of the decentralized decision-making in the 777 engineering teams. And I had the privilege of seeing Don Reinertsen present at the Scaled Agile Safe Summit in 2017. It was incredible because he describes his evolving thinking on how to enable decentralized decision-making, which he feels is so important in the modern age. So much of this was informed by his experience in the U.S. Navy as a submariner. He spent 6 years in active duty and 16 years in the reserves, retiring as a captain. And so given that, it was a little funny to hear how influenced he was by the U.S. Marines doctrine, which he held up as the gold standard of what effective decentralized decision-making looked like. Specifically, he talked to MCDP1, that's Marine Corps Doctrinal Publication 1. I'll put a link to it in the show notes. What caught my eye was how he described what high trust looks like in the U.S. Marines. They place a great emphasis on trusting superiors, subordinates, and peers, relying on 4 things: dependability, the certainty of proper performance of duty; integrity, nothing less than complete honesty in all dealings with subordinates, peers, and superiors is acceptable; unselfishness, looking out for the needs of subordinates before your own is the essence of leadership; and loyalty, faithfulness to country, corps, unit, seniors, subordinates, and peers, Semper Fi. And then you went on to talk about mission-type tactics, or Auftragstaktik. Wikipedia defines it as a form of military tactics where the emphasis is on the outcome of a mission rather than the specific means of achieving it. Don Reinertsen talked about the need to tell people why they are doing things, not what to do and how to do it. What goal, larger than the battle itself, are we trying to achieve? And I love this phrase, understand the commander's intent, at least 2 levels up in the organization. And he says, if you know why you are doing things, you can adapt better to changing conditions. It was an amazing, breathtaking presentation. And I'll just mention one more slide that really caught my attention. He talked about boldness and initiative, specifically about cultivating the ability to take calculated risks, that errors of over-boldness are dealt with leniently. And he cites MCDP1. And I quote, "Initiative, the willingness to act on one's own judgment, is a prerequisite for boldness. There must be no zero defects mentality. Abolishing zero defects means that we do not stifle boldness or initiative through threat of punishment." End quote. I thought this was absolutely fantastic, and I haven't read all of MCDP1, but it's going back to the top of my pile of books to read. I will put a link to all of these resources in the show notes. All right, let's go back to the interview. I love this, and I feel so privileged that to be able to see how your thoughts on this has evolved over time, including both that DevOps Enterprise talk as well as your writings on, I think you called it maneuverability in one phase. In the last podcast, I had interviewed my mentor, Dr. Steve Spear, and one of the things that I'm trying to do is be able to learn about what he calls structure and dynamics with the goal of, as parsimoniously as possible, explain how organizations work, how organizations behave. One of the things that I had shared with you 2 weeks ago was positing this notion that structure is the way the teams are structured as well as the architecture that we work within, which results in a whole bunch of dynamics that are almost a function in totality of the structure. And so there's something I found so magnificent re-listening to your 2018 presentation. I would call it the tale of 2 outages. One organization, in order to resolve an issue, they had to escalate 5 levels up and then down 3, right? And it might take hours or even days for the right 2 people to talk to each other to solve the problem. And then you paint this other extreme where those 2 engineers are immediately able to contact each other, right, and solve the problem together much more quickly. But you said this one phrase. You showed kind of the org chart, and you said something like, if you look at this diagram, regardless of what it shows, the comm structure, the service architecture, the software architecture, they're probably isomorphic, right? And I remember laughing when I heard this because it matches one of my own aha moments, which is really that you need an org chart and a software architecture that are congruent. And I love your phrase, isomorphic, because you're making an even stronger claim between the relationship between the org chart and how teams are organized and the architecture they work within. Mike, can you defend that claim?
Well, first I'm going to appeal to authority because I'm certainly not the first person to make that claim. I'm going to point to Melvin Conway and Conway's Law, where he said that the organization is constrained to build a system that recapitulates the communication structure of the organization. And I think that there's some really interesting parts to that, because for a while, people quoted Conway's Law as sort of a cynical joke. It was kind of in the same category as Murphy's Law. And then kind of around the same time as we started talking microservices, people started to appreciate the deep truth under Conway's Law, that it's not just a cynical observation.
The joke is, to paraphrase, I think this comes from the Devil's Dictionary. If you have 5 teams working on the compiler, you get a 5-pass compiler.
Yeah, exactly.
Based on a famous series of experiments he did in 1968 that he actually did a controlled experiment. 3 teams working on a compiler and 4 teams working on a compiler, and the 3 teams generated a 3-pass compiler, and the 4-team compiler generated a 4-pass compiler. So, I think that was kind of a very profound observation.
It was. And when you look at the mechanics that cause that to be true, what happens is 2 groups that don't talk all the time have to coordinate on a deliverable that causes them to negotiate an interface. That interface is then a boundary in the structure of the software. And so the boundary between the teams becomes a boundary in the software. Now, in terms of the org chart, this is where I think there's something really profound in what Conway said, which is that it is the communication structure of the org that creates that software architecture. The communication structure doesn't always follow the formal structure of the org. In fact, a very common pattern I've seen is a company goes through a reorganization for whatever reason or whatever purpose, but they focus entirely on the static structure, who reports to who, but they don't talk about how they want the behaviors to change or who your new collaborators are meant to be. Or more bluntly, how do you still get your job done when you're located in a different part of the organization? So, lacking that, people still need to get their job done. They will use the tools they already know. They'll talk to the people they already know. And so you get the formal structure and a shadow network or shadow structure. And it's the shadow structure that will determine the true architecture of your software.
So this is, I wrote down a couple things that we'll follow up on. But so what distinguishes in the tale of 2 outages? How is the structure different in the one you have to go up 5, down 3 versus the one where 2 engineers can just work together to solve the problem?
Well, that's the thing. The structure can be exactly the same. The formal structure can be exactly the same, but the incentives applied will create the communication structure, or I should say the disincentives applied. If you communicate directly with somebody and then get called on the carpet for it, or your manager hears from their manager that you were taking up time without providing a cost center number to charge the time to, et cetera,
right,
you're not likely to do that again. And it doesn't take very many instances of that before everybody sort of just perceives and models the behavior and emulates the behavior that you do things by going up, over, and down.
That's interesting. So yeah, there's a couple of variations on that, right? I can't get a feature in unless there's a project code associated with it, or I can't talk to the ops person unless there's some authorized service, something that will get logged against and charged to, right? I mean, those are the type of interfaces that are defined to make sure that you stay in your own lane for whatever purpose.
And what's fascinating is, with the best of intention, you can change the org structure, but the old structure may be baked into tools that become the operating system of the organization. So one that's on my mind, we use ServiceNow, and we have a service catalog of things that you can request, including a playground or a sandbox environment in one of our platforms. The form to request that included a field asking for your cost center. Even though the playground tier didn't do any chargeback. And so just the existence of that field meant a dev who wanted to try that out had to go find out what their cost center was. That means asking your manager or your director or whatever. And like, most people just don't want to do that.
Right.
So, by the way, we did get rid of that field, but it's really an example of something. I think Churchill said, "We shape our buildings, and thereafter they shape us." But you can say the same thing about the tools. You create the tools to facilitate processes for a certain org structure. Then you change the org structure, but you keep the tools. So you're stuck with the old processes.
And the tools are where we formalize processes and enforce, we hold people accountable, right? We define what the communication paths are. So maybe just to help with my own edification. So in the case where the two engineers are able to talk together, it is a part of structure, even though the org chart might look the same. There is actually an explicit interface that says, these people are allowed to talk to each other, right, to achieve a common goal. And that is not contradictory to the goals of each one of those silos. There's actually a common mission tying them both, right? So that is an element of structure.
I'll buy that. Sure. Absolutely.
It just reminds me of the book Team of Teams, where the silos were like Army Rangers, Navy SEALs, etc. But in the before case, right, you had the Army Rangers going out on raids, putting intelligence and evidence in duffel bags. And then you have the Navy SEALs doing the same thing. And you end up with profoundly bad outcomes. And it was actually the famous story in the book is how they were embedded into common mission teams. So the Army Rangers kept on reporting through the Department of the Army, Navy SEALs reported through the Secretary of the Navy, right? But when it came to short and medium term objectives, they were tied towards a very common mission. And now sighting to capture went from months, if ever, to in one case 45 minutes. So there was
that's phenomenal.
Oh yeah, so great, right? Yeah, so there was a structural change made, even though the org chart is probably the same. The way they interface with each other resulted in profoundly different outcomes.
So I might liken that to creating product teams that each have their own reporting hierarchy, but together are bound around the construct of the product.
Right, and the product goals. So let's go back to architecture again. And so I had this startling aha moment when I really heard and studied the story of the birth and death of Sprouter at Etsy. The short story goes back in 2008, in the bad, dark days of Etsy, they had this problem where in order for the company to ship a feature, two teams would have to work together. It would be the devs in the front end, inside of PHP in their case, and then the DBAs would have to work inside of the stored procedures inside of Postgres on the back end. And so it meant that features required two teams to communicate, coordinate, synchronize, marshal, and so forth. And so their countermeasure was to create something called Sprouter. So that was stood for Stored Procedure Router. And the goal was to be able to allow the devs and DBAs to work independently, and they would just meet in the middle inside of Sprouter. And as one of the senior engineers said, this required a degree of synchronization and coordination that was rarely achieved, to the point where almost every deployment became a mini outage. And if you're doing 30 to 50 deployments a day, right, this was like a real problem. And so there was actually many attempts to replace Sprouter, but then they decided to kill Sprouter entirely. And the goal was to fully enable developers on the front end to make all the required changes and be able to obviate the need for any backend changes because they used an ORM for that. And they found that whatever part of the property they eliminated Sprouter, suddenly, deployment lead times went way down. The deployment outcomes and success outcomes went way up. And so what I found so marvelous about that was I thought this was such an amazing example of Conway's laws. You go from 2 teams to 3 teams. They have to communicate and prioritize, right? The quality outcomes went down. And when you can get to a point where every team can make all the changes themselves without any dependencies on anyone else, you get all these great outcomes because you don't need to communicate and coordinate with anybody outside the team. And so that really shaped this aha moment that it is not enough to move those teams around on an org chart, that the role of architecture is as important as the way we organize teams. And incidentally, one of the biggest surprises for me in the State of DevOps research was that architecture is actually one of the top predictors of performance. And the marks of great architecture in the study were these. To what extent can teams make large-scale changes to their parts of the system without permission from anyone else outside the team? To what extent can they do their work without a lot of fine-grained communication and coordination with people outside the team? Can they release their service or product on demand, independent of other services they may depend upon? Can they do their own testing on demand without the use of an integrated test environment? A point of incredible coupling, if that exists. And if all those things are true, then suddenly you can do deployments during normal business hours with negligible downtime. It was such a aha moment to understand that these are the characteristics that allow for developer productivity, for better safety, for reliability. So, Mike, one, does that resonate with you? And what are the other attributes of good architectures?
First of all, it definitely resonates. I had not heard the story of Etsy Sprouter before, but it doesn't particularly surprise me that those outcomes resulted. In terms of the DORA research and the architecture qualities, I think all of those qualities that you described are the results of architecture, or the observable characteristics of architecture that provides safety. In other words, if you lack safety and you try to make a change in an environment that doesn't protect the rest of the environment, then your actions have outsized impact on everyone, or even the organization as a whole. And therefore, you will not be allowed to do a deployment without scrutiny, without fine-grained communication, and so on.
Just to confirm, so this is the phenomenon where I make a small change to my part of the system, and then some distant part of the system blows up. Something terrible happens, right? That's kind of a mark of poor safety.
Yes, right. In fact, I describe safety as the characteristic that the change you make within your team can only harm your team. And to the extent that the architecture prevents you from even harming yourself, you'll be even more courageous and able to make faster, more fine-grained change because you get that immediate rapid feedback. So there are definitely levels of safety that I would say enable these characteristics that are described here as the observable predictors of success. And as we've often heard, process is the scar tissue of past incidents. So it doesn't take very many incidents before those review processes and the scrutiny ramp back up. And the fewer fault isolation barriers you have, or the larger your failure domains are, the faster those review processes are going to ramp back up. So I think these findings don't particularly surprise me, and they do definitely describe characteristics of good architecture. There's something I don't see here, though, which is an attribute of predictability. In other words, am I able to predict the ramifications of the change that I'm making? Or if I make this change, is something far distant going to be affected? Or am I going to be harmed in the future in ways that I don't yet understand? Inability to change, higher cost of maintaining the old stuff, that sort of thing. And so I'll give a couple of examples to try to make that concrete. I worked with an e-commerce as a service company some time ago. They had a very rich templating language in their front end. So if you were a storefront owner, you could put quite a lot of logic into your templates. They also had a lot of customization in the back end. And many of the templates would invoke third-party services that would rewrite parts of the pages, right? So the effect was that the back-end developers never quite knew if any change they were making was going to be safe, because they had 2.8 million storefronts with every possible combination of templates. The templates were also stored purely in data in the production database and relied on proprietary item data, pricing data, customer data. So you couldn't even bring that data into lower environments to test out all the permutations. This created tremendous fear of change, which led to increasing cruft and legacy and buildup. So Kluge's cluster, and I wrote a blog post about this that I called the fear cycle. If you fear to change your technology, or you fear your technology, you will soon have reason to fear your technology. Right. So that aspect of predictability is one.
And in fact, just to concretize that even further, and so that's the notion, is that like of isolation? In other words, to what degree can you actually reason about and run your code in isolation without the other components? Is that seems like
that sounds ideal.
Yeah, right. Right.
Yeah, actually, it is. That's a great insight, Gene. The changes people made in the back end had no isolation because it was possible to break the storefront of a small business owner in Saskatchewan and not even know it.
Because you can't test in isolation, you can't run in isolation. Yeah, that's what seems to drive up the fear, right? It's easier to build things when you have that characteristics. It's easier to test it, and I think the assertion would also be that you can actually be more competitive when you have those properties in your architecture.
Absolutely. And don't forget the value of being able to delete things or shut things down. I mean, it's a little bit tongue-in-cheek, but we focus a lot on building. But I'm in a situation now where I can see what 5 decades of building with very little deletion creates.
Awesome. I interrupted you. Yeah, please keep going. Other marks of great architecture.
I would say that another aspect of it is that you don't need global knowledge. So I guess this is also isolation, but it's the flip side of the predictability. It's sort of saying no human can grok the full breadth of the environments. And so in some ways, the architecture either protects me from needing to have that global knowledge, or it makes that information visible at the point in time when I need it, so that it's sort of an evident architecture.
I love that portion of the interview. So I'll put a link to Mike's post called The Fear Cycle in the show notes. So here's the pattern that he writes about, and I quote, "Small changes have unpredictable, scary, or costly results. And so therefore we begin to fear making changes. And then we try to make every change as small and local as possible. And then the code base accumulates warts, knobs, and special cases, and fear intensifies." And so who hasn't lived with a code base where we fear to change it in exactly the way that Mike talks about? But he goes on to talk about what the real implications of this are. And again, I quote, "Add a few of these terrible events into company lore, and you'll find that developers and project managers become loath to touch anything outside of their narrow scope. They seek local safety. The trouble with local safety is that it requires kludges. The codebase will inevitably deteriorate as pressure for larger changes and broader refactoring builds without release. The vicious cycle is completed when one of those local kludges is responsible for someone else's "what? I didn't know that" moment. At this point, the fear cycle is self-sustaining. The cost of even small changes will continue to increase without limit. The time needed to get changes released will increase as well." So then he describes what is horribly the inevitable outcome. One of several things will happen, he writes. 1, a big bang rewrite, usually with a different team, and the focus will be, this time we'll do it right. The second possibility is large-scale outsourcing, and the third possibility is selling off the damaged assets to another company. So as humorous and terribly true that is, he writes about something that is even more unsettling in the next paragraph. He says, "The worst response to one of these negative events is a tribunal. And sadly, the difference between a technical SWAT team and a tribunal is mostly in how individuals in that group approach the issue. Wise leadership is required to avoid the fear cycle. Look to people with experience in operations or technical management." I love what Mike wrote, and it reminds me of one of the most delightful and amazing findings in the State of DevOps Report, at least for me. And it's this, is that there's one question you can ask that has a surprising ability to predict every one of the metrics that we talked about, whether it's deployment frequency, deployment lead time, change success rate, mean time to repair, or organizational performance metrics like employee net promoter score, or the absence or presence of technical practices, cultural norms, or architectural practices. And so this one question that you can ask is simply this. On a scale of 1 to 7, to what degree do we fear doing deployments? 1 is we have no fear at all. We just did one. 7 is we have existential fear of doing deployments, which is why in our ideal, the next deployment we would do is never. We're done deploying this code. And so I think that really shows that so much of what Mike talks about, you can actually see in the State of DevOps research. So I love this post. I I actually studied this post this week, which fortified me to actually tackling refactoring a code base that has been increasingly difficult and scary to change. And I'm so pleased with the outcomes, even after only a couple hours of work. So I encourage all of you to read the post. Back to the interview. Awesome. So, there's another example that comes to mind of just a phenomenal before and after picture, and that's the famous Amazon replatforming. By some accounts, Amazon spent $1 billion replatforming the Abidos platform in 2004. Werner Vogels wrote in the ACM that it complected all of the display logic, all of the business logic, the recommendations tool. Right, everyone had to teach the same things in order to get things done, and became untenable, unsafe, and a huge productivity hit. Right, to actually implement anything anymore. And as I reported by Steve Yegi, the big mandate went something along these lines: one, all teams will henceforth expose their data and functionality through service interfaces. 2, teams must communicate with each other through these interfaces. 3, there will be no other form of inter-process communication allowed, no direct linking, no direct reads of another team's data store, no shared memory, no backdoors whatsoever. 4, doesn't matter what technology you use, HTTP, Corba, PubSub, Bezos doesn't care. 5, service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose their interfaces to developers to the outside world. No exceptions. 6, anybody who doesn't do this will be fired. And 7, thank you, have a nice day. And then Steve Yegi writes, obviously number 7 is made up because Bezos doesn't care whether you have a good day or not. But the impact of this is so obvious now, looking 15 years in the future, right? Gene here. I realized I could have been clearer in that explanation. So Werner Vogels is the CTO of Amazon Web Services. I mentioned a famous ACM paper that he wrote that described the replatforming of the Abidos system. I'll include a link to that in the show notes because it's great, and I cite it heavily in the DevOps handbook. The problem in 2004 was that every team needed to touch the Abidos system, whether it was changing the display logic, the business logic, the recommendations engine, everything. And the consequence of that is that they were only able to do dozens of deployments each year. And so this was a huge problem. He wrote in a 2009 article that every one of these deployments required a long, unwieldy process requiring complicated coordination, and it limited our ability to innovate fast and at scale. Steve Yegi is a famous engineer who spent many years in the early days of Amazon, who then went on to work at Google. The Steve Yegi memo that I read from is a famous memo he released to Google Engineering describing some of the key components of that transformation. I think that this Amazon story is one of the most breathtaking examples of how an organization was able to change their architecture to enable developers and development teams to become orders of magnitude more productive. So in 2004, they were doing dozens of deployments per year. By 2011, they were doing 11,000 deployments per day. By 2015, they're doing 136,000 deployments a day. That's stunning. So Werner Vogel writes, to remain competitive, companies must increase their agility so that they can continually uncover new opportunities and create better products. Okay, so with that explanation of what they did and why they did it, let's go back into the interview. So to what extent does that resonate with your own experiences? It is, to a great extent, architecture that enabled Amazon to achieve their goals.
I love the clarity, precision, and succinctness of that memo. I'm always a little cautious about survivorship bias when we're looking at case studies. I remember reading a book called Sunburst, which was all about the absolute genius of Sun Microsystems and Scott McNeely in particular. And I picked it up, on the remainder shelf at the bookstore around the time that Oracle was buying the remains of Sun. And there are plenty of examples of books like Good to Great, where 90% of the companies profiled are gone or would no longer make the list.
I noticed that.
Yeah, so I'm cautious to say this memo was responsible for a tremendous technological change that succeeded. I don't know that it would produce the same success in other companies by just emulating the behaviors in this memo. I think there's a lot of Amazon DNA that's enormously hard to replicate. There are famous stories about Toyota giving tours to managers from General Motors and explaining all of just-in-time production and lean manufacturing to them. And when asked, why are you teaching us? We're your competitors, being told, if you get better, we all get better. But we also think that you're probably not going to be able to do this. Right? You'll copy the behaviors that are obvious and easy to copy, but you won't copy the mindset out of which those behaviors were produced.
So what are the takeaways that you think are universal?
So the paying attention to the structure is definitely universal. Creating and maintaining boundaries is universal. In fact, I go on at some length about the flaws in the typical layered architecture pattern for applications, that the boundaries erode very quickly and they all turn into a big ball of mud. In every organization where we've seen services and microservices succeed, they've paid tremendous attention to the nature of those interfaces and the boundaries that they represent. And this is where a lot of enterprises get service APIs exactly backwards. They take the existing system, figure out what they can expose from that existing system, and they turn it into an API. Right? What you should do instead is say, what does the caller want to achieve? That's my API. Stripe does this extremely well. I love Stripe's APIs. I use them as an example all the time. They are perfectly consumer focused. So that focus on the interfaces, very, very important. I absolutely believe that. I think the other piece of their DNA that's not expressed in this memo, but grew out of the transformation that this memo created, is the complete willingness to tear down and destroy things that you just got done building. In other words, that creative destruction process or continuing renewal process is really important. And that's another thing that most companies don't do. Most companies will take, say you have two projects at most companies, one of them delivered under budget, is performing well, has 3-4 developers because they're using a language like Clojure and they have superpowers, naturally. Another team, 15 people, behind schedule, over budget. Which one does the company put its funding into? Almost always, it's the over budget, behind schedule team. Most companies will starve the winners and force feed the losers. Amazon doesn't do that. So if you talk to the people working on the services, if your service is not getting traffic, if it's not getting customers, it's going to get deleted and you get reassigned.
That's
right? If you're getting customers, then you get to add on to your service. It's just the opposite of the way most companies work.
We are so much looking forward to the DevOps Enterprise Summit Vegas Virtual, which will now be held on October 13th to the 15th. As always, the goal of the programming committee is to bring you the best experience reports and to outprogram all our previous events. And this year, we expect to deliver on that promise again. I am so excited about the speaker lineup we have for you, partly because they are among the most senior technology and business leaders that have spoken at this conference, showing you how important the work of this community is. Maya Liebman is CIO of American Airlines, who presented at our annual forum in April, and we were fascinated by the perspectives that she shared with us. I'm so excited that she will be co-presenting with our longtime friend, Ross Clanton, about the American Airlines journey. And since 2014, we've all been dazzled by the CSG journey, as told by Scott Prue and Erica Morrison. I am so thrilled that this year, Scott Prue will be co-presenting with his boss, Ken Kennedy, Executive Vice President and President of CSG, the largest provider of customer care, billing, and order management in the U.S. Ken and Scott will be sharing their story on the interplay between business and technology leadership and how it resulted in their amazing accomplishments over the years. This is just the beginning. Stay tuned for more exciting announcements about our amazing speaker lineup. This will undoubtedly be the best DevOps Enterprise Summit program we've ever put together. You can find more information at events.itrevolution.com/virtual. That's brilliant. And so, and you talk about that in your DevOps Enterprise talk, which I absolutely love. So, what I find so dazzling about this is that as we're analyzing the Amazon "Thou shalt use APIs" story, it seems to reinforce this notion that one of the responsibility of leaders is not just to design the organization, but also make sure that there is an architecture that is suitable for achieving that mission. So I have two questions. One is you talk about reorgs, about who reports to who, how do you want their behavior to change, who are your collaborators, reorganizations done well, and ones that have done poorly. Can you give an example of the best reorgs you've seen? In other words, independent of the reason that led to it, what are the characteristics of reorganizations and structural changes that you would give high marks to versus the ones that you would give very low marks to?
Okay, well, I'll start with the lowest of low marks. There was an individual I worked with that would probably fall onto the chaotic neutral alignment in D&D, and he enjoyed drawing block diagrams that made no sense, were half truths, and included a bunch of weird parts that nobody had heard of, and leaving them on whiteboards in conference rooms. He once almost accomplished a reorg by printing an org chart on a remote printer in a different floor of the building and just leaving it there to see if people would start behaving that way. And for context, he was doing this as an experiment because sometimes reorgs were communicated in that kind of a haphazard way. You would sort of hear...
this is what starts a rumor mill, or triggers certain responses, whether it's fear or ambition or greed. Is that right?
Yeah. You would hear, over lunch, somebody says, "Oh yeah, you're reporting to Bob now." You're like, "Oh, okay." So you go talk to Bob, and you're like, "Hey, Bob, am I on your team now?" And Bob's like, "I guess." It's a funny story because it's sort of an extension to the extreme of patterns that we've actually seen, right? Managers that don't understand why the reorgs are being taken or what's being moved or who, failing to change the incentives to match the new structure, failing to explain any of the rationale about why you're doing this or what you expect people to do differently. That's what puts it on the poor end. The reverse end has all of those things, and it improves feedback loops, closes broken feedback loops where they have them, aligns people's incentives with their positions, creates clear areas of authority where they can, at recursive levels of the organization, then you know what your parameters are, what's expected of you, what you're allowed to do, what your constraints are, and you're able to link that to that big vision that I talked about, the actionable vision. That's a good reorg.
I remember hearing a great story from a friend at HPE. It was a group in Israel that took over the management of the Mercury test director tools. And he said he inherited this project, and to develop a feature, you had the front end engineers work on one thing, then the back end engineers work on another thing, and then the middleware team working on another thing. It was for any given piece of work, you had to line up 3 different teams with their own different set of priorities. And it really was extraordinarily difficult to even do small things. And the notion of then slicing up the product into different slices and then moving all of the relevant members of the front end, back end, and middleware teams into one spot so that decision making could be localized, that they could do their work without any dependencies. I think in that before case, his name was Ruli Weissbach. He said, one of his engineers said in a very Israeli way, "Really, I don't think you are a very good manager," because this is a terrible way of working. And in a matter within a year after they put in this, they turned everything around and ended up with this incredible way of implementing features that were not only more productive but had better outcomes and happier engineers. So that seems like that would be an example of a good reorganization. Does that resonate with you?
Oh, it totally does. I'm curious, in that situation, do you know if they split the code bases out to align with the new team structure, or were they still working, in 3 different chunks of code, but now had all the people and talent necessary in each feature team?
I don't know, but I will find out. So
Okay.
it threw me sufficiently motivated. It was DevOps Enterprise London.
My friend and colleague Stefan Tilkov talks about self-contained systems, SCSs. This is one of several alternatives to microservices that he's put forward. So each SCS goes all the way from GUI to backend to reporting. So we might consider them macro services or mesoscale services. But again, it's the same idea that you can do everything you need to do from front end all the way through.
And I'm thinking about sort of like that taken to an extreme. So you have a bunch of teams that are autonomous. They can achieve their own goals with their own independent backlogs, with their own kind of independent success metrics around, what the specific goals for that feature area are. There was a talk at DevOps Enterprise from it was the old Rally Software people, where an architecture group was stood up because they couldn't help but notice that there were 3 different JavaScript UI frameworks. I think it was React, it was
Angular, perhaps,
Angular,
or Backbone.
right. I think they had all 3, which I didn't actually know was possible to have all in one app, but because the teams had so much autonomy and authority to make technology choices, you did end up in these horrendous situations where you can imagine there are some very negative effects that can happen when you have 3 JavaScript UI frameworks all extant in the same place.
Yeah, I think the way that Stefan would answer that with the self-contained systems is that moving from one SCS to another is a page load. And so you're not trying to load all of them in one place. But I know that there are other companies that have gone down the path of micro front ends, where you create the thinnest possible central set of standards. And it's very tough with the front ends because of the nature of JavaScript. You don't have good isolation between different chunks of JavaScript being loaded. So there are points where you necessarily take away some of the team autonomy to create a better experience for the user. That challenge of trading off autonomy and ability to make independent change versus efficiency pops up over and over again. Shared libraries, shared services, shared technology platforms. I don't think there's a static resolution to that. I think you kind of always end up going too far in one direction and pulling it back and going in the other direction.
So I was going to, before I get to the question about leadership and architecture, I would be remiss if I didn't ask, Mike, what is your definition of architecture? We talked about some of the properties or outcomes when you have a good or bad architecture. I mean, what definition do you use in your thinkings, writings, and doings?
So to me, architecture is the organizing logic of the components and the materials used to construct them.
Holy cow! What does that mean? It sounds so good.
Yeah, it requires a little unpacking. So organizing logic is one of the first pieces that I really look for. When you look at the patterns of interaction or the patterns of construction, do you see a rationale behind it? Is there coherence to the problems being solved? So, for example, if you tell me that you've got microservices, you've told me almost nothing about your architecture, right? I know something about the construction of the components, but I know nothing about how they're allowed to interact. You could have a Death Star diagram, right? The dependency topology where everything calls everything else. You could have everything communicating in CQRS style through a common message bus. Right? You could have a body of the butterfly where you've got front-end services that call an API layer that calls a back-end services. Those are architectures. Each one has a different organizing logic. If you told me you were combining all of them and putting a butterfly in CQRS stuck to a big ball of mud, I would say you have no organizing logic. But the other aspect is about the orderly construction of the things that you're creating. So architecture is really about time. If we could create any system as fast as we needed, we would never worry about the architecture. You would just always be coding. But we can't. It takes time to build something. And because of that, once it's live, we need it to run for a certain period of time to pay itself back, to have a positive value on the thing we've built. And so there will be a period of time where you are under construction with everything you make, and different pieces will be under construction at different times and different stages of the construction or deconstruction or replacement. And so we need that organizing logic to extend not just across the space of the system as it is in any given moment, but we need it to extend across time so the system makes sense at every point in time, now and into the future.
And one part of that is that if all these components are being built in parallel, it sure helps to be able to test them and integrate them at places, not just at the end. It seems like one attribute or requirement of what you just said in terms of the orderly construction.
I mean, we've definitely found that integration gets worse the longer you let it go, right? But there's a lot of interesting stuff in that area. I don't know if it's going to take us off topic or in a different direction, but when we build what I'll call a modern architecture, which is heavily API oriented, service based, relatively small components running in their own processes. Most of those interfaces are what I would call very loosely typed. They're essentially dynamic in nature. You pass in a blob of JavaScript, JSON. You pass in a GraphQL query. Actually, GraphQL is probably not a good example because it's more strongly typed. But what it means is I don't have any compile time checking on my large-scale architecture. Right, so everything is deferred to runtime, and I find all my errors once I try to actually run things. Well, so that's exactly like you're in the dynamic language camp that says the speed of building things dynamically exceeds the cost of the runtime errors and fixing those. But there's definitely an alternate path you could go down and say, I'm going to have strongly typed interfaces, and that those types are then how I communicate between the parallel streams. I synchronize my thinking and yours by defining a type that represents our shared understanding. And that would be along the lines of a protobuf or gRPC-based architecture.
And you had an amazing article about that in terms of scaling, about if the goal is to enable teams to work independently without a lot of communication coordination with other teams, not because we don't like talking to other people, but that does slow down the ability for teams to get things done. Your assertion was that static typing and broadcasting, that is a phenomenal time saver, that let alone the correctness advantages that you can get out of it. It is just it's a great way to signal and broadcast and enable other teams to get their work done. Did I characterize that?
Oh, you totally did. And I'm tickled pink that you read that. You're one of like only 50 people who read that post.
In fact, my reaction was that wouldn't it be interesting if that it was actually that advantage that drove us to static typing, right, as opposed to the more mathematically oriented assertions that you can make around static typing. Gene here again. All right. That blog post that Mike wrote was titled Cost of Coherence, and it is such an interesting post. So he talks about the cost of maintaining coherence across teams. And so he writes about what that cost might look like. He writes, for example, for a half dozen people, you might just put them in a single room. That penalty might be very small, just a whiteboard session once a week or so. But for a large team spread across multiple time zones, it could be large and formal. Documents and walkthroughs, presentations to the team, and so on. And he gives specific guidance on how to reduce the cost of coherence. He says, take a look at your architecture, language, tools, and team. See where you spend time reestablishing coherence when people make changes to the system's model of the world. He says, look for splits. Split the system with internal boundaries. Split the team. Use your environment to communicate the changes so recohering can be a broadcast effort rather than a one-to-one conversation. And look at your team communications. How much of your time and process is devoted to coherence? Maybe you can make small changes to reduce the need for it. So I think these problems are so important. How do you enable productivity at scale, not within a team, which is pretty easy to do and I think well understood at this point. But instead, how do you enable hundreds or even thousands or even tens of thousands of developers to be productive, working together towards common goals? This is at the scale of not teams, but teams of teams and within an enterprise. Okay, back to the interview. So this gets to my question that I've been leading up towards. Let me frame this first with my own prejudices. So there have certainly been times in my career where I've been very disenchanted and about reorganizations. I think that sometimes for reasons that you've stated, let's put on kind of like malicious dynamics that can exist in some senior leaders, right? Reorgs are often, when I hear about a reorg, often my body language is like, oh no, it's like we were doing so well. Like, why are they doing that? And yet, through the lens of structure and dynamics, right? The notion that, so much of the dynamics are a function of the structure we create. It does seem that, org changes are a very powerful tool in the arsenal that leaders use. And then when you combine that with the notion that as you get higher and higher up in the organization, that you have fewer and fewer knobs to turn. That, the notion that, the more senior you get, the more power you have, and now you can make everything so. Turns out really not to be the case. It really is, your primary knobs are about structure, architecture, and of course, then modeling the dynamics that we want to create, as you mentioned, right? These things that engender trust, whether it's through vulnerability, authenticity, right? Clarity of mission, right? A succinct message that everyone can see how their daily work helps advance is or is not connected to the grand goals. So it seems to me that most leaders, they're far more comfortable in how the org chart looks versus the architecture. And if the assertion is that architecture is isomorphic, right, meaning there's a one-to-one relationship between the two, then there's a deficit on the expertise needed to make good architectural decisions. So can you comment on that? And really, maybe it's leading to the question of to what extent do leaders need to be responsible for the architecture, and how do you make them sufficiently informed to enable the right types of architecture?
Oh, wow. There's a lot to unpack there. First of all, I somewhat agree that you have fewer knobs to turn at higher levels in the hierarchy. A lesson that I've learned, sometimes painfully, is that indirect influence can be just as powerful as direct control. And that's been brought home to me, especially in organizations that are very sensitive to the hierarchy and to titles and levels, because some people are inclined to snarky remarks or cynicism or being facetious or flippant. But especially in large companies or global companies, the nuance of that being a facetious comment or "I'm not serious, I was just kidding about that," that nuance can be lost. And especially when it goes from somebody who was there with you having a beer together when you said, "I don't know why Apache needs Kafka and Pulsar, one or the other should do," right? And then you hear back a week later, like, "Oh, Nygard hates Pulsar." I'm making that one up. That's a fictitious example of a pattern that actually has occurred. And you're like, no, look, that was beer talk. But the thing is, when you are in a leadership position, in a sense, there's no such thing as beer talk. So you have to be very careful with your words. But it also means that you have ways to communicate your intentions and that people will hear those and resonate with them and communicate them and so on. And they're going to do that whether they agree with your intentions or not. In fact, it may happen faster if they disagree with your intentions. Right. What that means is sometimes the changes you introduce don't have to be org changes. They don't have to be a blunt instrument of changing someone's annual goals, right? It can be as much as saying, "I think we need to use messaging more and rely less on synchronous communication because we're moving from one location to multiple and we can't always wait on the round trip time." Right? And you say that 10 or 12 times in different ways and the message gets across. So there's that. But the question you asked was about whether leaders needed to know more about architecture and how that interplay between org and architecture could maybe go both ways. And I think that there's this sort of fun ambiguity in the term enterprise architecture. And I know that it's a term that sometimes is denigrated and sometimes rightly denigrated. There are a ton of pitfalls. We've all seen the Ivory Tower EA group. We've all seen the outdated yet mandated enterprise framework that everyone is supposed to use. So I get it. But you can interpret the term enterprise architecture in two different ways. One is defining the IT architecture at sort of enterprise scale and visibility. The other is it's the architecture of the enterprise itself. And there are some books and some professional orgs that try to make that distinction even clearer, to say that enterprise architecture is a discipline entirely separate from enterprise IT architecture. They may have lost that battle. But it is absolutely the case that in my current role, I'm trying to work on both sides of the fence, advising on the architecture of the organization, the static structure and the dynamic structure. Also advising on the architecture of the software and trying to make them work together, to be congruent.
Right. In fact, or one can even say that the software really needs to be subordinate to the business architecture.
Certainly.
One constructs the software architecture to best serve the architecture of the business. I'm not sure if I'm splitting hairs here, but that seems like a very profound observation.
I think trying to ascribe cause and effect or say that one precedes the other is pretty difficult, because the truth is they're both going to co-evolve. What's possible to do in the software architecture is constrained by the current org structure, and what's easy or feasible to do in the org structure is constrained by the software architecture as well.
But in any case, right, the goal is to make them mutually reinforcing, congruent, isomorphic.
Yes, absolutely.
Right, as opposed to not, right?
Yep.
Totally. So therefore, if that's true, then to what extent are leaders responsible for being aware of creating, truing up the architecture as it serves the goals of the business it serves? Is this something you safely delegate to the VP of enterprise architecture, or what do you need from them?
Well, that's a great question. I feel like I need to consult with Mark Schwartz before I can really answer that question well. But
actually, I know how to ask this more directly. So can you talk a little bit about what it's like being responsible for, quote, enterprise architecture, and what are the best attributes among the counterparts that you deal with, whether it's technology leadership, business leadership? What are the most helpful characteristics in those working relationships?
That's a question I can absolutely answer. Thank you. So one of the things, it's a lot like trying to create a large-scale change in your software through a sequence of, an uncountable number of small refactorings. So, you extract a method here, you inline a variable there, but you have a picture in mind of where you're trying to go, and you want to get there, but everything has to keep working at each step along the way, right? If you're doing refactoring well, there's no point at which your tests all completely fail, and if you're doing your org change well, there's no point at which all your revenue stops, barring global pandemics.
Right. I'm laughing, but it's not funny, but
yeah, I mean, sometimes gallows humor is all we've got. But what I mean is, we're trying to engender continuous change in the org, but without blowing it all up at any point along the way. It has to continue working. And so in doing that, I'm continually working with the other leaders in the company, talking with them all the time. And one of the things I've found is that most of them would actually like to know more about why things are the way they are.
Mm.
So I won't say that they're all happy with IT or happy with tech or product development. There's plenty of frustration to go around. But the frustration, in my experience, the frustration doesn't just lead them to sort of pull the lever that opens the trap door that drops you into the shark tank. What it means is they would like to know why. Why is it like this? And I don't know, you can probably tell that one of the things I like to do is kind of teach and share what I've learned and what I know. So there are people in my company that I spend an hour with a week just talking to them about what the nature is of our systems and of development in general. And very often, after a few of these, they start to go, wait a minute. When you're talking about these big batches going into development and causing these problems, like that's my BRD that I wrote. Like that was hard work. We wrote 300 pages in the BRD. I'm like, yeah. Imagine if you could have written one page and just had a conversation about that. Wouldn't that be easier? And imagine then that like 2 weeks after that conversation, you could see that bit running. Even if it doesn't go all the way to your customer, because they have to take a long time to adapt to the change or adopt the change, but you could see it running. Wouldn't that be better? You know, that it isn't necessarily as fast a process as we would always like, but it's building that kind of rebel alliance, except it's a rebel alliance of people who are VPs and above.
Right. And so that story seems to speak to the process, the nature of the way we build software. I have to imagine there are equally big aha moments that deal with the architectural processes. So it's not about the methods, but the orderly construction and patterns of action, organizing logic. Can you share one like that?
So this one gets a little tougher, and I'll take an anonymized example. Let's talk about a company that operates in many geographies with many customers who take different forms of payment. So one way to deal with that is to maintain a table internally that says, I know these customers take these forms of payment, and so I'm only going to present the options in the GUI that I know that they take. Another way to approach it would be to say, I'm going to let them tell me what forms of payment they take, either at request time or whenever they feel like it, they can just send me an update to what forms of payment they want to take. The first way requires us to do something when they change. Right? Either it's baked into the code or it's in a database table or a config file, depending on how rapidly we expect it to change. The second one puts the control on the customer side. There can be valid business reasons to go one direction or the other. So deciding that as an architecture decision alone doesn't actually solve it. Because sometimes we have to have a contract in place to accept a form of payment on their behalf. Sometimes there are government restrictions that we may not know about ahead of time to take a form of payment on their behalf.
And so these would cause one to constrain the choices so that we don't get into a position where we're accepting or processing something we shouldn't, right? That's the direction that takes us. Yep. Okay, this is great.
Now I'm going to add a wrinkle. By having that connection with the leaders on the business side as well, you can present them another alternative, which says, I'm going to let the transaction processing software call out to ask if this form of payment is accepted for this carrier. But that's going to be another service of ours. So it's kind of a middle ground where we are maintaining the information, but the service that's applying the logic isn't the one that is maintaining the database of information. And so now, at this point, it's a little like the scene in Amadeus, where the guy looks at the score and says, I don't like it. Too many notes.
That's right.
Because
Salieri,
now we're talking about
right?
more parts.
Was that Bach or Salieri or Mozart?
It was one of the court musicians about Mozart, I think.
Nice.
So it looks like more parts. It looks like more complexity, which makes people think it's going to take longer to build. But you and I know from our work in Clojure that sometimes separating things into different concerns that are each extremely simple to build, the net time for building it is less and the net complexity is less. And so that's a place where we would need to talk to the product leader about the architecture and explain, doing it this way looks like a net increase, but it's not. And you're creating benefits for the next iteration down the road and the iteration after that.
That's so great. On my face, if you can't see me, I have this giant grin as Michael's explaining to me that it is not a bad thing that there are too many notes in the score, but there's actually could be a potential great business advantage and simplification and maintainability and so forth. So how does it feel like when you can successfully persuade someone to go towards this simpler design?
Well, those are the days that I feel like, I might actually be qualified for this job. As opposed to the other days where, you get blindsided by something and you're like, man, what? I don't even know what I'm doing here.
That's awesome. Gene here again. Oh my gosh, I love that last bit because it shows the sophistication and understanding of the problem domain and the sensibilities of what makes great architecture. How doing things in a way that looks more complex actually makes things simpler and easy to build upon in the long term. Listening to him, I actually had a flickering flash of insight and understanding, meaning it was exhilarating to see what he saw, but I'll admit I didn't actually fully understand it. In other words, I certainly couldn't explain it to someone else at that moment in time. And if you didn't quite get it, fear not. I did a follow-up interview with him where I got to ask him to explain this concept in more detail, and it was fascinating. I think it's something that every senior leader also needs to understand. I'll be airing that follow-up interview in the weeks to come, just as we did for the Steven Spear interview series. Okay, back to the interview. You had this magnificent quote when you were interviewed by Karen Meyer on the Cognicast podcast about how engineers have to be able to talk in the language of business. We need to know something about how business people work, budgeting, capital versus expense, balance sheet, time value of money, getting benefits now versus getting benefits later. And you had this great concrete example of, yes, we need to hit some date in July, but we now eventually need to take 2 weeks after that before we do anything with the single sign-on issue, because presumably to pay down technical debt. Mike, can you talk about that quote and why it's important to you and any advice you would have to technologists about how better to communicate with business leadership?
I'm glad that you enjoyed that discussion because I think it's hugely important. And since that interview on the Cognicast, I've given even more thought to the way that engineers communicate. And so I want to go a little further. When engineers talk to other engineers, they don't want to be seen as condescending or belittling the skills of the other engineers. So what they'll tend to do is describe the situation and leave it to the other person to infer the consequences or assume that the other person understands the consequences. And so I might say something to you like, our Oracle rack cluster is supposed to be 4 nodes, but 3 of them are running 5 minutes behind on replication. And, as someone with an engineering background, you go, holy crap, 5 minutes of backlog? That's terrible. We've got to fix this right now. But someone else might hear it and kind of go, okay, and Oracle rack is what? That's where we hang coats? It's in a bakery? What kind of a rack is this? Sometimes as engineers, when we're communicating to people outside the engineering discipline, we need to kind of remember that the person we're talking to may not have the experience or background or baseline knowledge to draw the conclusions we want them to draw. And so at the risk of seeming pedantic, you have to develop a personal style that lets you do this where they understand you're trying to help, not condescend. You kind of go, so if we have a problem with our database right now, we're going to lose the last 5 minutes of order data, and we might not be able to recover the last hour's worth of orders. And then they go, oh, that sounds bad. And then you translate it to dollars, and you're like, yeah, the last hour we took $97,000 worth of orders. And now you're beginning to speak the language that they speak, time and money and schedules and resources. Gregor Hoppe talks about the architect's elevator, that especially as an architect, you have to be able to ride the elevator from the boiler room, where you're talking to the people who have their hands on the real work. They keep things running. And you ride the elevator up to the boardroom, where you're talking to the people who, to them, the boiler room is kind of an abstraction. As long as the heat is on, they're not too worried about how it happens. And so you have to be able to speak both those languages. So yeah, I do talk a lot about engineers translating into the language of the leaders they're talking to. There's one more point, though, that I'd like to make, which is something engineers don't realize is that most communications in business are negotiations of some kind. And so when you are simply stating facts or answering a question, you may not realize you're actually engaged in a negotiation. So someone will ask an engineer a question that appears to be a technical question. Could you do it in 8 weeks instead of 20? You're like, well, we could if we do X, Y, Z, and W, where the consequences of X, Y, Z, and W should be horrifying, but the person hearing it doesn't have the baseline knowledge to draw those conclusions, right?
Perfect.
And they're like, great, do it. You've got 6 weeks. Like, what do you mean 6 weeks? I thought it was 8. I'm sure you'll have it all done in 4 weeks, and I'll talk to you then. What?
Exactly.
And so one tactic is the engineer needs to recognize it as a negotiation and counteroffer. Could you do it in 8 weeks instead of 20? Absolutely not. No way. In fact, we really need 24, or it's going to be screaming hellfire around here. Or counteroffer with a request for the other things you need. Say, we can do it in 8 weeks and then an extra 20 weeks to deal with issue X, Y, Z, and W, because each of them is costing us 10,000 hours a year in maintenance. Right? So again, these seem like simple strategies, but they're definitely patterns that I've seen over and over again.
I love it. Mike, I got to tell you, I have a big grin on my face, and I'll have a smile on my face for the rest of the day because you've explored in such detail things that I so much care about. And just to be able to hear your experiences and learnings over the years is just an honor and a delight beyond words. So thank you so much for that. Mike, tell everyone how they can reach you.
Well, I'm on Twitter. I'm pretty active there as MTNYGARD. And you can use the same @gmail.com to reach me by email.
Awesome. Thank you, Mike. Thank you so much for listening to today's episode. Up next will be Dr. Steven Spears' DevOps Enterprise Summit presentations, both from 2019 and 2020, where he talks about the need to create a rapid learning dynamic, as well as how to create them. The 2019 presentation talks about many of the case studies we talked about today, but in more detail. And in 2020, he talks about one of the most remarkable and historic examples of creating a dynamic learning organization at scale, which was in the U.S. Navy at the end of the 19th century at the confluence of two unprecedented changes. One was in the underlying technologies which you found in ships, and in the strategic mission that they were in service of. As usual, I'll add my reflections and reactions to those presentations. If you enjoyed today's interview of Steve, I know you'll enjoy both of those presentations as well.